All right, this is Professor Pelton. This is part 2 of chapter 3, part 3. So now we're going to look at intervals of increasing and decreasing. So we'll just list them down here on the bottom. So we'll be increasing, decreasing, and constant. Okay, we'll put some colons here. All right, so we're going to start left to right. So over here, this is going up to infinity. So that's obviously when you read left to right, we're currently decreasing. So from negative infinity to, let's see here, we have 1, 2, 3, 4, negative 5, right? So to negative 5, we're decreasing. Okay, but at negative 5 specifically, we're neither increasing nor decreasing because that's a change point. Okay, so from negative 5 to, let's see, negative 1, 2, 3, negative 3, we're increasing. Okay, but at negative 3, again, you can't use the brackets because at negative 3, you're neither increasing nor decreasing. Okay, so we're constant from negative 3 to negative 1. Okay, so at that point, it's an inflection point. So we could probably put brackets around those ones. But prior to that, it's not. So we're just going to do that for the meantime. Okay, so from negative 1 to positive 1, we're increasing. So union, negative 1 to positive 1, we're increasing. And then we're decreasing again. So union 1 to, what is this? 1, 2, 3, 4, we're decreasing. Okay, and then we're constant again from, oh no, we're increasing. I'm sorry. We're increasing again from 4 to 5, right? But not specifically at 5 because that's a change point. Okay, so then we're constant again from 5 to infinity. Okay, that's not a very good 5. Let's fix that up there. Okay. All right, pause the video and try student problems for yourself. Okay, so you don't always have to have all 3 parts necessarily. So we're going to do intervals of increasing, decreasing, and constant. Okay. Okay, so again, you read left to right. It's the way you read the graph. So in the beginning, we're increasing. So from negative infinity until 0, we're increasing. So from 0 to 2, we're constant. And then from 2 to infinity, we're increasing again. So 2 to infinity, we're increasing again. So at no point are we ever decreasing, which is fine. Okay, so for the next one, we are increasing from negative infinity to negative 2, and then we're decreasing from negative 2 to the asymptote, which is negative 1. Okay, we're decreasing there. Then all of a sudden, from negative 1, okay, union from negative 1 to 0, right? We're decreasing again. So we're decreasing here. But why didn't you notice I broke it up though? Because we don't actually reach negative 1. Negative 1's not included because there's an asymptote there, essentially. Okay, and we're increasing again from 0 to infinity. So at no place are we actually constant. So this would be none for decreasing here and none for constant here. Okay. All right, let's go to the next part. So next is the concept of extreme values, right? So your extreme values are either absolute or relative. So understanding the change in intervals from increasing to decreasing, which we just did, is how you understand maximum values and minimum values, right? Because if you go from increasing to decreasing or decreasing to increasing, as a result, you'll have a maximum minimum value. So it's a question of, is it absolute or not, meaning there's no other one that's higher. Okay. To keep in mind that the plural of maximum and minimum is maxima and minima, right? So maxima, minima, right? Okay. So let's take a look at these graphs and see if we have relative. Okay, so one thing I should mention before we go on, though, on Pinwheel of Death, is relative maximum is also called a local maximum, right? It's relative to its location, it's local, okay? And absolute is also called global, okay? So it depends on the book and the pretense of what you're talking about, but absolute and global mean the same thing, and relative and local mean the same thing. Okay, so if I look at these particular graphs here, right? This is an absolute min, okay? It's also a local min, right? This is an absolute max, and this is also a local max, okay? This over here, okay, is a relative or local. We'll say local max. How's that? A local max. Or however you want to put it. I'm just abbreviating here because of the amount of room. You shouldn't abbreviate though. So absolutes are also local or relative, but locals or relatives are not necessarily absolute. Okay, so if we look at the next graph, this is still an absolute minimum or relative or local minimum, right? But these ones, the points don't exist, so therefore there is no extrema values there because you can get infinitely close to those circles or open dots or open points that you never actually get there. Okay, so the next one, so this is an absolute max, which is also a local maximum. Okay, this one right here is a local maximum. This one right here is also a local maximum. You're asking yourself why. It's just a singular point. Well, when you look at the definition, the points that are immediately before it and after it are lower than this actual point here, correct? So by definition, it actually works. Okay. All right, so we go to the last one here. So this is the absolute max, which is also a local maximum. This one right here is an absolute min. It's also a local minimum point. This one right here is also a local maximum point. Okay, and just because a point is listed does not mean it's either one, because the points before it are higher and the points before it are lower. So by definition, it's decreasing in both all the way through. So it's neither a minimum nor a maximum. All right, pause the video. Try the student problems yourself. Okay, so we look at this one here. This one is an absolute min and a relative min or local min, however you want to put it, doesn't matter, it means the same thing. Okay, this one is an absolute max, right, and a local maximum or relative maximum, however you want to put that, doesn't matter. Okay, these ones are open, so you cannot count those either way. Okay, so this one's tricky. This one has no extrema values. Well, this is the highest value, but there's a hole there, doesn't actually get there, right? And this is an asymptote that goes down forever. It keeps going down forever. So there is no minimums basically. And this point that's listed here is neither a max nor a min because the points before are less and the points after are more. So it's continually increasing. It's not a relative extrema whatsoever. All right, the next one, this is an absolute max or global, I'm sorry, minimum, minimum or global minimum, right? It's also a local minimum. Okay, this one right here is an absolute maximum or a local maximum. Can be both, right? And if I look through here, this is a local min, and this one is a local maximum. Okay. because remember, locals or relatives are not absolute, but all absolutes are local essentially. Okay, because all the points before and after this coordinate of 1, 0 or higher, so therefore that's a minimum, right, by definition. All right, so this is an absolute max. That is an absolute maximum. It's also a local maximum, correct? Local maximum. There is no minimum here because that point doesn't actually exist. There's a hole there. But this is a local max, this point here, right? That's a local max, 0, 2, because the coordinates before and after it are lower than it. So by definition, it fits. Okay, so the last one, this is an absolute min. It's also a local minimum. Okay, and there is no absolute or local max because this goes up forever. Okay, and it's just continually decreasing the whole way. So there is no absolutes. Okay, that's the end of part 2.